review, but I'm going to just put a little Algebra 2 spin on it. But today we're reviewing the quadratic formula. Hopefully you'll understand the quadratic formula a lot more, because I'm going to put some meaning into it. So when we can't factor, and when we can't solve by square rooting, we can use the quadratic formula. It's just another way of finding zeros. That's what the quadratic formula does for you, right? It enables us to be able to graph a parabola. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Some important properties with it. The discriminant, this part, it's not with the square root, it's just what's underneath the square root, tells us how many roots we have. Okay, let me give you 3 different scenarios. So let's say we have, I come up with an answer of negative 3 plus or minus the square root of 20. That's what we were just doing, right? So that tells me I've got 2 different roots, correct? I've got an axis of symmetry at negative 3. That's my axis of symmetry. And I have, in the positive and the negative direction, the square root of 20. The square root of 20 is almost the square root of 25, right? So isn't it almost 5? So I would be going out 1, 2, 3, 4, 5, somewhere about here would be a 0. And 1, 2, 3, 4, 5, somewhere about right here. That's what that tells us. Sometimes we get something like a perfect square. So negative 3 plus or minus. I'm trying to think. Sometimes we have nothing underneath there, right? Which you'll see in just a minute. What would that mean? What would that graph look like? I'm at negative 3 still, is my axis of symmetry, and what are my roots? I only have 1. No, I have 1, it's right here. It skims, right? Only 1 root, because it's going to be at negative 3, but it's not going to go to the right or the left at all, right? It's just going to skim it. And we saw something like that. We saw things like when we factored, that would be one of those, right? A double root. Well, we have one more. I guess I should. So that's 2 roots. We have one more scenario that we're going to talk about today. When I have a negative sign underneath there, it means I still have an axis of symmetry. My axis of symmetry is still at negative 3. But guess what? I'm not going to have any roots. I'm going to have imaginary roots. It means that my parabola is never going to touch the x-axis. Okay? So all of that comes from this part of this formula. So if it's positive, you're going to have 2 roots, right? Because that's why we've got the plus or minus. So it's going to go in one direction and the other. If it's a 0, we're going to have 1 root, and it's going to be on the x-axis. It's a double root. And if it's negative, we're going to have no roots, right? No, we're going to talk about that. We're going to be able to figure it out. Okay, so let's look at this example that I've got here. I've got 2 different roots here, right? I have a positive 2 and a negative 4. So I have those written in there. I also know another piece of information. What else do I know about it? The y-intercept. The y-intercept is at negative 8. So down here. also know the axis of symmetry is right here at -1. And I also know, since a parabola is always symmetrical, then I must have a point right here as well. But the discriminant here tells us, from the very get-go, I knew there were two roots, because 2 squared is 4, minus, well actually this is going to be plus, 32. So I got 36. So I know I'm going to have two roots. Another piece of information. You see this right here? Before I said it was our axis of symmetry, it still is. But you're like, but Mrs. Muller, it says -2, and we said our axis of symmetry is -1. Well, let me show you. I'm going to just keep it on this one. Right here, it's our axis of symmetry right there. Because if I have both of these things being divided by 2, isn't that what that says? The whole numerator is being divided by 2? Then wouldn't it be -2 divided by 2, plus or minus all that stuff divided by 2, which is really -1. Okay, so 2 bits of information here. This tells me how many roots I have, either 1 root, 2 roots, or no roots. And this tells me my axis of symmetry. There's actually a formula for it. It's -b over 2a. But that's not something you have to memorize because it's right there for you. So when any time you want to use, you want to find your axis of symmetry, you can just plug in your b and your a. All right, let's work with it. Yes? Yep. It shows you so much, right? The quadratic formula just tells you so much. Okay, let's play with this. Right here, what remains describes the center of the root, -b over 2a. Same thing. I just did it all on one slide. Let's work with it. So this is the worksheet that you're going to get. You're going to get something like this. There's 2 different things that we can get. We can get the vertex and we can get the discriminant. So first of all, before I do anything, I need to ask myself, is that factorable? What's factorable about it? Yes. 4. It's got a GCF of 4. So I can pull out a 4, and I get x squared plus 2x plus 1. Is this factorable? Is it? Can we factor it? Well, where's the x? Ask yourself. So I have 1, and I have 2. Is there something that when I multiply, I get 1, but when I add, I get 2? 1 and 1? Does that work? So it is factorable. It's actually 1 and 1. How did we do that last week? We put this in front. I already forgot. You guys help me out. That magic way that we factored last week, it's x and 1 and 1. And then if we have a coefficient, we divide by it, correct? No. If we multiplied by it, then we divide by it. So it would just be that. So what do I know about this? What do I know about my graph? What does this tell us? What? It's going to skim the x-axis because it's a double root. So I know all of that because I can factor it. But this is going to be kind of like my check. It is factorable, but I'm going to go over here and I'm going to find the vertex and the discriminant using the quadratic formula. So B happens to be 8, so I have negative 8, and A happens to be 4, so I'm going to put 2 times 4, which equals negative 1. Negative 8 over 8 is negative 1. Well, if I were to factor this, I already knew I was over at negative 1, right? And I already know it skims the x-axis, and I know it has a y-intercept at 4. 1, 2, 3, 4. And since it skims, I already knew that this was my axis symmetry. And I already know that since it's symmetrical, so I already know that my parabola looks like this. This is not a V. I had several of you graphing parabolas like this. It's not a V. It's a U. Sometimes it looks like a V, but it's a U shape. Okay, my discriminant. So what should my discriminant come out to be right now? We said your discriminant's going to come out 3 different ways, either positive, 0, or negative. If it's positive, you're going to have how many roots? 2 roots, right? If it's 0, how many roots are you going to have? 1. And if it's negative, how many roots are we going to have? None. We're not going to have any roots. Okay, so let's do the discriminant. So b squared, so b is my 8, so that would be 8 squared minus 4. My a is 4, and my c is 4. Oh, I need purple. Let's see if I'm right. So 8 squared is 64. 4 times 4 is 16. 16 times 4 is 64, and I get 0. So this confirms exactly what my picture says. How? Because I have a 0 discriminant, that means I know I only have 1 root. And this part of the quadratic formula tells me I have an axis of symmetry at negative 1. I have an axis of symmetry at negative 1, and it's skimming, so I only have 1 root. Yes? Yes. You plug in your axis of symmetry, exactly. That's how you find your vertex always. Okay, so what about this one? Is it factorable? Let's check. I have 8 and negative 6. Can I get an 8 if I multiply, and if I add, I get negative 6? Negative 4 and 2? Does that work? So this is factorable to x and negative 4 and negative 2. So without even doing any of the work, I can already graph this. I know my zeros are at 4 and 2. 1, 2, 3, 4. That means my axis of symmetry is where? X equals 3, right? X equals 3, and I have a y-intercept at 8, which makes sense. And then since this is 1, 2, 3 away from the axis of symmetry, 1, 2, 3, I also know that there's a symmetrical point there. And here's my graph. So my whole point is to know that I can actually have a picture if it's factorable. Now let's double check it. So my vertex, my axis of symmetry, oh, I was supposed to find the vertex on the last one. Sorry. So like Kane said, in order to find the vertex, I just have to plug negative 1 back into the equation. So 4 times negative 1 squared plus 8 times negative 1 plus 4. What does that equal? Well, negative 1 squared is just 1. 1 times 4 is 4. 4 minus 8 is negative 4. Right? Am I right? So I have positive 4 Minus 8 is negative 4. Negative 4 plus 4 is 0. And so my vertex is at negative 1, 0, just like we have here. I think you guys just need to get into this. Okay, negative b would be negative. My b is negative 6 over 2a. My a is 1. So my axis of symmetry is positive 6 over 2, which is positive 3, which is the same as my picture, right? Well, I'm finding the vertex underneath it. First, I have to find the axis of symmetry. I have to find the x, and then I can find the y. By using the axis of symmetry, I find the vertex. Good question. So I'm going to plug this in. So I have 3 squared minus 6 times 3 plus 8. 3 squared is 9. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. Correct? So my vertex is at 3, negative 1. Does that work with my picture? 3, negative 1. That looks like it's going to be right on, right? Yes. That would be wrong. And then I'm going to double check that I have 2 roots, right, with my discriminant. So that would be b squared. My b is negative 6 squared minus 4. My a is 1. And my c is 8. So if this becomes 0, there's only 1 point, right? Because it's not going to the right or the left of the axis of symmetry. It's just 0. And if it's something bigger than 0, there's 2 away from the axis of symmetry. And if it's a negative, there's none. No roots. So this would be 36 minus 32, which equals, what does that number mean to me? Root 4, what's the square root of 4? 2, right? Divided by, how do I know? 36 minus 32 is 4. No, it's fine. And then if I had that 4, let's look back at just looking at the whole thing. I have a negative b plus or minus the square root of b squared minus 4ac. I'm going to write it separate. All over 2a, all over 2a. I don't know why they don't write it like that. It makes more sense. Because what's this? That's my axis of symmetry, and what's this? My roots. Right? This is I don't know why they make it so disconnected, like it's this quadratic formula, and most people don't, you plug stuff in and you don't even know what you're really finding, right? This is the quadratic formula, right? This finds my axis of symmetry. This finds the roots. You use it to find the vertex because you plug it into the original equation and it finds the y. This is only the x part. Let's play with it. You ready to do some homework? Okay, let's see if I need to show you anything else before we go there. All right.
Wait, are we just done doing the square rooting stuff though? Because...
Nope, we're never done.
Okay, no, good.
Yeah, we need to continue to be doing we need to factor. Like for instance, this one, couldn't we use the square rooting method on this one? Right?
But we'll see it again though, right, the review?
Yes. Okay. What else do I know about this? I know the y-intercept is -5. What else do I know? The vertex is 0. The vertex is 0, -5. How do I know that? By just looking at that. Because what? There's no b. so it's not shifting this way. You guys can't look at it yet and tell me anything more about it? I can graph that right now without even doing anything. There are x-intercepts. It has to do with that right there. The function family, yes, Bryce. I know that this is a parent graph. What does this tell me? No, it's shifted. Where is it shifted? Down 5. Right? So you guys already know like so much in your toolbox of quadratics, right? You guys know all kinds of things. You should be using all of those things. I look at this and go, I already know that it looks like this, right? 1, 2, 3, 4, 5. I already know. I'm hoping, Bryce, that you will too. I've given you all these tools, right? Hopefully it'll all start to make sense. I can solve by square. It's not factorable, but I can solve it by square rooting, right, Aaron? If I move the 5 to the other side, it's just x squared equals 5, and then I take the square root of both sides, and I get x equals plus or minus root 5, which is a little more than the square root of 4. And what's the square root of 4? 2. So it means I have zeros that are a little bit more than 2 in this direction and a little bit more than 2 in this direction. And on the test, there's going to be certain questions that will ask you, because there's only one more thing we're going to do. We're going to complete the square too. So it'll ask you things like, what do you have to add to both sides to complete the square? You can't use a quadratic formula for that. So you know what I mean? You have to know all methods, because I'll make sure I ask questions that lead to your full understanding of all of the methods. Okay? Absolutely. Yeah. Okay. So I'm going to go ahead and pass out your homework so you guys can get started on this. I don't think I need to show you anything else. Ooh, we'll do this when we come in tomorrow. I want to put this in your folder. I mean, in your notes. I'd rather you just get started on homework. Okay.